Okay, friends and neighbors, I know you've been waiting. We just got done talking about the problem, right? Why in the world we needed DNS to begin with, what were the issues? And so now let's talk about what the actual solution is. Before we get to the nuts and bolts of DNS, let's talk about what a solution might actually look like, right? What do we need to have in this solution? Well, we need a consistent namespace to begin with. And what that means is that no matter what resource you're trying to access, no matter where you're trying to go, no matter what kind of lookup you're trying to do, everybody's got to do it the same way. And all of the lookups or all of the resources requested have to look exactly the same way. So in that way, no matter who is passing this information along, no matter what server might be talking to another server, everybody's names have the same sort of structure, and that's really, really important. Now, in addition, there's no concept of address or routing information or anything else that's part of that name. It's just a name. Now, unlike DHCP, which has local significance, meaning that there's a DHCP server or a set of DHCP servers that run inside an organization, DNS is global. And that means that there's the huge potential for lots and lots of updates, lots and lots of queries. So the idea is that servers are maintained locally or by an entity, but the requests and the ability to query different servers is decentralized or distributed, meaning that everybody can participate and servers can talk to each other, but there's no one central location for all of this information. It would be impossible. And if you think about the sheer number of nodes, or even the size of the IPv4 address space, if you were to sort of map that to all the different possible hosts that might be in that space, it would be enormous. And even if you could do it, the lookups on one file like that would be really, really time limiting. So not only the system, but the management, the update, all of those things are distributed. Now, another important idea is that it's not just for one thing, right? You're not just using this namespace or the system for one particular application, websites or mail, right? What if we come up with a way to name things that could be used across applications? So that's another really, really important idea, and one that might be survivable should a new application be created. Well, that doesn't sound too difficult. Geez, is there anything else that you'd like with your system? Well, because everybody's going to do things a little bit different. Everybody wants to have, names based on their ideas of what is meaningful. It ought to be that instead of just using a particular format, we want to have a way to have a query look for that particular resource identifier or that particular, I'll say it now, fully qualified domain name, and that the space that is being used to store, right, the database or the files that are used to store all this information are structured themselves. On top of that, we want a particular structure to what we're going to call the namespace. So there's no room for unstructured or non-standard data in a system like this. Everybody's got to do it in the exact same way. And then lastly, this system is going to be completely independent of the communications substrate or the architecture that runs underneath it. So it doesn't have anything to do with your network, your routers, your connection to the web, anything like that. It is a completely separate managed system that sits on top of all of that. So let's see if we can provide a solution for all of those things. So it turns out that the solution proposed by RFC 1034, hint, hint, wink, wink, has three main parts to it. Now, there's a lot to the operation, and we'll get to all of that, but there's three main parts. First is the domain name space itself. So this is what we call the DNS tree. So as this little graphic indicates, there are different levels to the tree, and you have to work your way up the tree to find answers. Now, sometimes you can find answers to your queries very low on the tree. But as queries get more specific or they're different types, you work your way up the tree to find answers. But everybody uses this same tree. It's really, really important. When we add what we might call a low-level domain to the tree, all of the parts of the namespace that are above it in the tree are included in the fully qualified domain name. So that becomes an important idea. All right, so we have the namespace. Now I just want to take a second here to take a look at this term space. We use the term space a lot just to sort of put a wrapper around or a label on all things that are possible. So we have address space. So if I have a network and the network has a certain range of IP addresses, that range of IP addresses is my address space. On a computer system, there's a certain part of the file system or a certain part of the processing that is allocated to users. That's user space. And then there's a certain part of the system or the resources that are allocated to the system itself. So in DNS, we have the namespace. So all of the possible names that can be generated from this tree is called the namespace. Now, another component of our proposed solution is the name server. The name servers, as the name would indicate, is a server. So what is a server? A server is software, right? It resides on a machine somewhere or in a virtual machine, and it reads the files that we've been talking about. So the domain namespace structure is contained within these files, and everybody does these files in the exact same way. So all of the resource records are contained in these files, and the server is there to answer queries from clients or resolvers. A client can query a server, and if the server knows the answer, it can provide the answer to the client. If it doesn't know the answer, then the server has the ability to query those upstream or tell the client where the answers might be obtained. Now, a server can also retain information that it has learned. An important concept here is that this is decentralized. If I create a network and I have all of these resources that I want folks to get to, then I will have a name server locally. But in order to get to the outside world, my name server has to talk to other name servers. And then out there on the world, there are all of these other administrators that are running their name servers. Together, everybody doing it the same way, all of the resources that might be publicly available are going to be in this vast collection of name servers. But no one name server has all of the information. Now, the last part of this is the resolver. And this is the client side. Every host that needs access to resources has the ability to do what we call querying. So a query can be formulated by a resolver, and then it goes and talks to the server. So a resolver is your client software, and you query a server, and the server answers with whatever it knows. And if it doesn't know, then we have to pass it off somehow to the next level of domain name servers. So when we configure hosts, we let them know about at least one name server, usually a local name server, and maybe there's a secondary there as well. So one thing that we say is that the resolver is the client side, but every server can also be a client as well. So there's our three parts. We have the namespace, we have the servers, and we have the resolvers. Well, enter RFCs 1034 and 1035. Again, part of that early generation set of RFCs, and they're largely in use as they were originally created. Although you can see from the little graphic that I added to this, they've been constantly updated. Now, 1034 has the description of the overall system, and it has a lot of terrific historical data and the reasons why we do things. So I would absolutely encourage you to go out and at least read the first couple of pages of the RFC. But as it says here, it's an introduction to the domain name system and omits many of the details which can be found in 1035. So these are actually good size RFCs too. So the actual implementation is in 1035. Now, as I said earlier when we were talking about the requirements for, a solution, we want not only for everybody to do it the same way, but we've got to have this way to query in a very, very structured way. So DNS is not just that you got this server and the resolvers out there and they're talking to each other, and then the system itself in the decentralized manner. It's also this protocol that exists. So this very, very structured, formatted protocol that is used to query servers. So as I just mentioned, 1035 has a lot of the details regarding the implementation of DNS, right? How does it actually work? What are things you want to watch out for? How should things structured? What are the kinds of records that you want to have and things like that. So I'll just put this out there right now that resources can be identified by different types of records. So in every one of these server files, there's a line that says, here's how you access this resource. So it might be as simple as, here's the address that goes along with this, this domain name. But we have different kinds of records, right? So that might be an address record. So we have different kinds of records to help us have a clearer idea of what a resource might actually be, or an indication as to how the servers might process the information. Well, now we know the solution, so we got the big picture, hopefully, right? We've got this decentralized system with the namespace itself, the servers, the resolvers, and then we got this protocol that runs between them, and it's highly structured. Everybody does it the same way. Okay, terrific. But we don't really know how it actually works. We don't really know all of the pieces, parts. So what we're going to do in this video series is we'll go through an authoritative server build, and we'll talk about all the parts as we go. Well, thanks for watching. Thanks for listening. Like and subscribe if I helped, and may your packets always reach their properly named and formatted destination.